Hello, this is Steve Bonacontri from SOA Consulting Services giving you a presentation on Amazon Cloud Mobile Solutions. In particular, we're going to talk about the AWS Mobile Hub and some aspects of building the application, some architectural introduction on how Amazon services are used with the Mobile Hub. And just remember, SOA Consulting Services, the AWS implementation experts. We specialize in Angular, Node.js, AWS, web services, etc. And I do have some code examples and presentations associated with this particular project on our website. Under resources, you'll see some AWS Mobile Hub links there to access code associated with this project. Okay, so what is the AWS Mobile Hub? Loosely speaking, it's a dashboard where you go and generate a mobile application that uses Amazon Web Services in the back end. So basically what you do before you generate the app, you choose what kind of AWS web services you want to use, and based on those, the application generated, let's suppose it's an iOS Swift application, it will have the SDKs in the application generated and sample API calls to each one of the services. So you basically get something right out of the box which runs and uses Amazon Web Services, and in particular, it also would generate access control policies within the Amazon web service space that give anonymous users and authenticated users certain permissions to do certain things from the mobile app. So let's just first describe what AWS services are being used with the Mobile Hub. First of all, there's a Cloud Logic service. Loosely speaking, it is a concept called Lambda functions, which are exposed. They can be written in Node.js or Java and different types of languages. We did all our implementation using Node.js. We used and a lot of the functions that we're calling are Lambda functions, and those Lambda functions use other services within AWS. There's NoSQL, which is a DynamoDB, where our Node.js applications actually persist user data and other application data into the NoSQL database using REST and JSON and some of the APIs associated with the DynamoDB database. There's something called mobile analytics, basically that registers analytics associated with your mobile hub application. When did the user fire up the application? When did the user end the application? How many users are using your mobile application? There's a dashboard which shows graphics and some analytics. Out of the box, there's calls to the generated Swift application, which is actually making calls to mobile analytics, generating all these results. And although they're limited, it's a starting point where mobile analytics are being gathered and retrieved and visually represented. There's something called Cognito Identity. Cognito Identity does the federated the federated identity capabilities. There's a user pool it can work in conjunction with called Cognito User Pool. Bottom line, Cognito Identity will issue a security token to the client application, so the client application can identify itself as an anonymous user or an authenticated user, and based on that, Cognito Identity allows the user to perform certain operations on certain web services within the AWS realm. There's something called user data storage. where the mobile user can upload files into their private space. And they could also store data and resources into a public area that all the mobile users of the mobile application can access. There's app content delivery, where web resources can be stored on common directory networks using CloudFront. That distributes your resources all over the world, so a mobile user logging in from the other side of the world gets their resources as fast as possible. And then there's SNS push notifications, that simple notification service from Amazon, which allows an administrator to broadcast out notifications to all the anonymous mobile users, all the authenticated mobile users. It allows one mobile user possibly to send a notification to another mobile user. So when I created my Mobile Hub application, I said I wanted to use all these features, and my application that was generated was a Swift application for the iPhone, and it had hooks into all of these different services, and we had the ability to look at user interface in the generated app to be able to test all the different calls to the web services. Now, the Mobile Hub application that's getting generated, let's say the Swift application at this point, is using the AWS SDKs to make calls to these different services. So just keep that in mind, that there is API calls generated, and there's custom API calls you have to make to do certain things in your Swift generated Mobile Hub app. And just to sum up here, like I said, there's authenticated users and there's unauthenticated users. And in the AWS space on Amazon, there's the Identity Access Manager, which provides permissions for users, for applications, for an application associated with Cognito and a user pool, permissions for a function to store something into DynamoDB NoSQL database. So there's permissions and access control everywhere. And the good news is that when a Mobile Hub application is generated on the web service side in Amazon, the access management policies are all created for you automatically with a starting point. That is, anonymous users of this application, mobile application, have certain permissions to do certain things. Authenticated users of the mobile app have the ability to do certain things. Okay, so let's move on. We talked about access control. So I'll do this by introducing access control for an unauthenticated user. Okay, so we've generated this Mobile Hub application. It's a Swift application. It's running now on all these mobile devices, and users are downloading the application, installing it on a device, and now they're using it, and they're not authenticated yet. Okay, so they have certain permissions as an anonymous user to do certain things. Now, what has happened here is that when this application on the mobile device gets fired up, it will ask Cognito Identity for an anonymous token that we could use, so we could use services on Amazon as an anonymous user of a mobile app associated with the Mobile Hub generated services. So for example, let's just assume now that we have an unauthenticated group of users using the mobile app, and Cognito has issued this access key. Now, Cognito issues an access key and a secret access key, and then there's this concept of it uses both those keys, like a username password, to create some sort of signature. And since the mobile application that running on the mobile client is using these SDKs, some of this stuff is happening implicitly. As a matter of fact, just want to make one point, using the SDKs from the AWS SDKs from Amazon, there is a lot of stuff that's going on the mobile device and being passed to the Amazon Web Services via the protocol, which is intriguing. It's just you get a lot more for the buck using the SDKs, and I'm just comparing that to the API gateway. But let's get back to this. Okay, so the Cognito Access Control controls your services on Amazon. So, for example, for Cloud Logic and invoking certain Lambda functions and storing stuff into a database or doing any updates in a NoSQL database, we could have a certain access control for that realm, which denies any anonymous users from accessing those services. Okay, so in addition, inside Amazon, I have a root account and I have a user who has administrative capability, and that administrative user here can use a dashboard to configure push notifications and create a topic. A topic which maybe the mobile application, when it starts up, subscribes to that topic. Okay, so let's go down the Cognito providing access to certain things as an unauthenticated user. Okay, first of all, the user can register. It registers against Cognito Identity. Now, Cognito Identity has a registration capability, but you need a user pool behind it. You could use your own custom database. We're using the Cognito user pool. So there's Cognito Identity pool, there's Cognito user pool. I'm showing you one icon that's representing both of them. But keep in mind, Cognito Identity does certain things. I kind of view it as it's the security server. It's securing all your resources. At the same time, it's allowing you to do federated identity. I could log in with Facebook, log in with Google, and I'm getting certain capabilities once I do that. But the user storage behind the scenes is provided by Cognito user pool, and that uses the NoSQL database. So when I set up Cognito, I set up, here's my user profile attributes. And here's the characteristics about the attributes. And so when a user goes and registers, there's some mandatory attributes. There's some other things associated with the registration which I can control. But bottom line is, when the user registers, they're registering through the Cognito. So the anonymous user can do several things. They could register, they could verify email, they could log in, they have a forgot password, they need to call that. They could receive notifications, and they could send analytics. Now, about sending the analytics, mobile analytics generates analytics. And so the mobile app that got generated by Mobile Hub is actually making calls to mobile analytics saying, this user started using the application, this user ended using the application. So I go into the mobile analytics dashboard, I could see, oh wow, I have 1 million mobile users using my application. But only 5 of them concurrently are being used at any point in time. But I could see the average amount of login time is only 10 minutes. So there's things I get from the analytics dashboard right out of the box, which are extremely important and valuable. On the other hand, if I log in, if the user logs in and logs out, and I want to know the average time as an authenticated user, I might have to implement those calls using the AWS SDK inside my mobile application. So just keep that in mind. Now, receiving notifications. Yes, my application is running on the mobile devices. We coded it up to subscribe to this topic. As an anonymous user, this topic you can subscribe to. That's just the way we roll. That's how we configured the access control associated with this particular topic. An anonymous user can subscribe to it. Okay, so now let's take a look at the next slide. And just to sum up this slide, anonymous users are registered with Cognito Identity, and Cognito Identity controls what they can access, as well as what the administrator can actually do as far as pushing notifications to them. Now, for the authenticated user, it's a little bit different. Now, here's a situation where I registered, and I got an email saying verify your email. I verified it, and now all of a sudden I'm registered and I go log in. And so at that point, Cognito Identity has given me an access key and a secret access key for my authenticated user, and there's now a signature associated with the app. And so every time the user is performing a function with the application, that request goes over to the Amazon cloud, and the permissions are associated with an authenticated user of the mobile app and Cognito user pool. So just keep in mind there's all different levels of security here, and you'll see that when this mobile app gets generated, there's all aspects of an application and its security policies are defining access in different points in time with different services, with etc. All right, so what can you do with Cognito? You could list the user info. You could change your password. You could update users. You could update your user information. You could receive notifications. You could send notifications, and you could also send analytics. So now keep in mind, there's the mobile app, which might be sending analytics, and there's the user, which might be pointing and clicking and updating their user profile information. In either case, there are events, and those requests go over to the Amazon cloud, and it's Cognito and IAM, the Identity Access Management within Amazon, which controls what can happen. Okay, so notice I opened up the Cloud Logic, because now that I'm an authenticated user, I could actually call my Node.js applications, and my Node.js applications can update my NoSQL, and also as an authenticated user, let's say a mobile user can send a notification to another mobile user when they push that notification to the simple notification service that the administrator has set up. That notification service has an application associated with it, which is pointing to let's say Apple's notification service, and Amazon's simple notification service will push the notification to Apple's notification service, which then talks to the mobile device and sending the notification to the receiving mobile user. So when you look at the Cognito and the push notifications and everything that's going on with the Amazon services, and you think about the mobile hub application, its goal is to provide functionality for the mobile user, communication mechanisms, to have a notification service between mobile users, and have these mobile users categorized as friends, as groups of users that you can perform certain operations on. Authenticated users, anonymous users. You might even create a different group of users who are sales reps, etc. So let's move on. Okay, so let's go through some of the scenarios. So this user registration. Now you have an unauthenticated user using their mobile app. The mobile app was generated by Mobile Hub. Inside the mobile app, there's code there that says when the app fires up, get me a Cognito Identity access key. This mobile app, this user can now register with Cognito to use the mobile hub services that we have behind Cognito. When I say that, identity access management is allowing certain permissions of certain functions within the Amazon Web Service realm. Like, for example, Lambda can talk to NoSQL. So there's identity access management policies which are giving permissions to certain functions, as well as the administrator who's administering the application. This particular mobile user only has a certain limited set of permissions given to it by Cognito Identity. So this user can register, and when the user registers, it's registering with the Cognito identity. Okay, so it's saying, here's my user profile attributes. I want to register. Cognito Identity says, well, I have a user pool with some of those attributes backed by NoSQL, DynamoDB. So I'm going to look at certain things. What's the mandatory fields? How many? What are fields? What are the required fields? And what are the any kind of validation that needs to happen? Now, Cognito Identity with a registration allows you to trigger functions, and you have to build those functions if you want to invoke them and define them. So we define a pre-registration Lambda function, which is a Node.js application. So before this user gets registered, we do a pre-registration Lambda Node.js application, which might do certain things. Let's make sure that the email ID is valid. Let's make sure that I might convert something to a user ID. Whatever I'm doing in the pre-registration Lambda Node.js application, I define it, I deploy it, I configure it as a trigger in the registration process. Now, there's a custom message Lambda function, which I also deploy and I trigger. That says, okay, this user is requesting to register. Let's validate his email. So a custom message Lambda will construct an email that says, hey, you're using Steve mobile app, verify your email. And the user will verify the email. And in that scenario, when they verify their email, we're ready to say, okay, we're going to give you a user account. But what we do before that is we invoke a post-user confirmation Lambda, which basically allows me to write a Node.js application to do what I need to do in the database or sending email or anything else like that. So let's suppose I send an email that says, you've received, you now have an account, you can log in. And I'll give them the, might give them some information that it might need. Okay, so the bottom line is Cognito Identity will do some things for you. You can configure it to give the user the standard responses. You could say, no, I'm going to implement triggers. Allow me to control what those responses are because I want to give them incentives to do something else as well. And so I write these custom Lambda functions to do whatever. Whatever the process may be, the bottom line is after the registration process completes, you have the user profile in DynamoDB. And you could also, the administrator can also go into the mobile analytics and actually see what has occurred while the user was using the mobile application anonymously. Okay, so the other functions are verify email, forgot password, send a custom analytic. These are things you could do as an anonymous user. Okay, now the user decides to log in. The user still has the unauthenticated token from Cognito, and now the mobile user says, I want to log in. So once again, the mobile application that the mobile hub generated is using an AWS SDK, which allows you to log in. It is the Cognito aspects of the API associated with logging in, and you make this function call called login, and Cognito identity says, this user wants to log in. So the goal for Cognito is to say, you've logged in, I'm going to give you back an authenticated token, right? But Cognito identity says, do you have any triggers set? Yes, you have a pre-authenticated Lambda, you have a post-authenticated authenticate Lambda. So it starts invoking these Node.js applications. And these Node.js applications, the pre-authenticate Lambda, the post-authenticate Lambda, allow me as a developer and an application administrator and developer to define what's going to happen. Now, I'm logging things to the console. So the Lambda function, as it's executing, is saying, oh, this user's trying to log in. Oh, and post-authenticate says, oh, this user has successfully logged in. So my Lambda functions are logging things, and CloudWatch is logging things as well implicitly, but it's also logging my console output. So when I go into the CloudWatch logs, I could actually see user started authenticating and completed authentication successfully. And I'm also, for debugging purposes, I might be logging information that I might need to see, like the user ID or whatever. Now the Lambda function is also persisting things in a NoSQL if it needs to store things or retrieve things or double check things or switch things. The Lambda function, they're all Node.js applications that are automatically managed by Amazon. They're automatically scaled by Amazon. All I'm doing is deploying the Lambda application, and Amazon is invoking this Lambda functions as a managed service. So there's a nice feature there that comes along with the mobile hub and the Amazon Web Services, is that I'm using all managed services here. So I'm not maintaining any server-side code. This can be viewed as a serverless architecture. Okay, and once again, the administrator, once the user authenticates, the user winds up with an authenticated token, and the user is now using the mobile hub application as an authenticated user. The administrator can log in and see, oh, we have a logged in user in Cognito identity. And they could look at the mobile analytics console and say, oh, wow, I see I have 10,000 users logged in now, and I've got 30,000 anonymous users who aren't logged in. Gee, I wonder why they're not logging in. I wonder why they're not registering. Let's broadcast out some messages and try to influence them to do so, whatever. So there's a lot of stuff going on the server side to help facilitate the success of the mobile application. Okay, so very quickly, updating user, change password. These are things you have to do as an authenticated user. So the user that's logged in, Cognito Identity has bumped up their privileges to an authenticated token type user, and now that user wants to change password, and Cognito Identity says, sure, I'll change the password. And behind the scenes, it's passing that, delegating that over to Cognito user pool, which uses the NoSQL user repository, DynamoDB, and at the same time, it might use an email server to send a message saying you've changed your password, blah, blah, blah. Now, when you go to update user from the mobile hub application running on the user's device, the update function call on the SDK, which invokes Cloud Logic, occurs. That's a user profile Lambda function which we implemented to update the user profile. And everything logged goes to CloudWatch, and user profile update can go against NoSQL. And I believe you could also do an update user on the Cognito SDK directly to update a user if you don't have anything special that you might need to do within a custom application code. Okay, so once again, identity access management is the thing that's basically saying, oh, you want to update the user profile attributes? Are you part of this user pool? You have a mobile application. The mobile application has certain permissions, and this user is authenticated against the user pool. So the user pool users have certain permissions to do certain things, and therefore the user, some of the operations the user performs are allowed within Amazon. Okay, now this is I'd have to say this part of the application and managing endpoints and making sure a user on one mobile device can send a message to another mobile device, and trying to determine what comes out of the box with Amazon and what doesn't is probably the most challenging things of this project. Trying to understand, what do I need to manage? What do I need? Do I need database tables? Does Amazon Web Services do a lot of this automatically for me? So let's just go through it really quickly. So here I am on the right. I'm administrative console. I'm an administrator, and I want the user to be able to send notifications. So the administrator has to create a platform application in SNS. And basically what that means is you wind up getting an Amazon resource indicator of your platform application, and you configure it to point to Apple's notification push service. So it's sort of like when you create the application platform, it's really working in conjunction with Apple. Or if I created a Google something for Android, I would need the application ID from Google and create a platform application. But we did all this initially in Swift. So we created a platform application by first going to Apple, getting an application ID, going to SNS, creating a platform application, and then basically there's certain steps in the application, the mobile hub application code that we have to do. Okay, so the first thing is when the application fires up, number one, we register for push notifications with APNS, Apple's notification service. A device token comes back, and we have a device token on the device now. Now, implicitly, the mobile application and SDKs in Amazon are going to make sure that certain data gets propagated to request to Amazon Web Services. So that device token is an important thing that's on a device. But number three, we get an unauthenticated token from Cognito Identity. Now that we have an anonymous token, we create an endpoint with SNS, and we store the endpoint locally. The endpoint identifies the mobile application running on the device and the device token. Okay, so imagine it: 10 users on their own devices with a mobile application, the same mobile application. How do you distinguish between the different devices and the different users? Well, there's a unique device token on each one of them, and creating the endpoint ARN using that device and storing it on the client is the thing that identifies that endpoint. Okay, now so now that this user has the endpoint ARN, you can send that user a notification. To that endpoint ARN, you could send a notification. Of course, in an anonymous, what was I going to say? What I wanted to say was that there's two scenarios: anonymous users who are not logged in, and users who are logged in, and notifications can be sent to each set of those groups separately. But I'll get back to that. Okay, so now we've established an endpoint ARN for this mobile user, and it is also registered in SNS. Okay, and the point that it exists now, we can send a notification to it. When I say we, I'm trying to be vague here. So let's suppose I just talk about the administrator right now. If they wanted to send a notification to that user, they could do it, even though the user is an anonymous user. Okay, so first, let me just explain to you some things that we've done just to set up our environment. First of all, we created these topics: a create endpoint topic, an update endpoint topic, an endpoint failure topic, and a delete endpoint topic. Basically, what I claim now that I created these topics, I define events associated with each one of these topics. When an endpoint is created, an event gets notified to the create endpoint topic. Anyone who subscribes to that topic, if they can subscribe to that topic, if they have the privileges to subscribe to that topic, will get notified of that particular event. Okay, so what we also did was we created Lambda functions. One of them is a create endpoint Lambda function. It's coded with Node.js. It's deployed on Amazon Cloud using the managed services, and it's logging into the CloudWatch, and it's registered with the topic called create endpoint topic. So if anything goes onto this topic, this Lambda will be notified, pick up the event, and I can take the endpoint and put it into the DynamoDB database. Okay, once more. A user gets a token from Cognito Identity. They create an endpoint with SNS. SNS now says, oh, I have an endpoint. Anyone wants to send them a notification, you might be able to do it. I create a topic which is listening for create events. Since that user created an endpoint, it went on to a create endpoint topic, and this Lambda function, create endpoint Lambda, was registered with that topic, so it gets notified with that event. Lambda picks up that event, looks at the endpoint value, the user ID, whatever came over with that event, and it stores in DynamoDB, let's say, the email address and the associated endpoint, or the user ID and the associated endpoint. So in this particular scenario, we are managing a table of endpoints and user IDs. And the reason why we have to do that is if I need to send a notification to a user ID, I need to get their endpoint. Now let me point out, when we did this project, query capability in SNS was not available. We did store the user ID with the endpoint in SNS because you could store additional data. However, we then had to go and update it with the email ID. So not to get into any confusion, the bottom line is we're using email IDs as user IDs. And email ID has to have a corresponding endpoint, or else one email address can't send to another email address, etc. Now let me point out, before you do this project, take a very close look at what you use for what you use for user IDs, because it seems natural to say I'm going to use the email ID, but there's consequences, and just take a look at that, and we'll see where that's heading. But we did use email IDs for user IDs. All right. So anyway, point is, we set up some capabilities. Now, there is a point in time in the application where the mobile user and the mobile app deletes their endpoint out of the system. And therefore, we have a delete endpoint topic, and that message goes into that topic. We have a delete endpoint lambda that gets notified of that event, and that delete endpoint might delete the email ID and endpoint in the NoSQL database associated with that user. So, like I said, there's a lot going on here, but it is relatively simple once you get it working. And as a matter of fact, some of these I have here for convenience. Of course, if there's an endpoint failing, I go to send a message to an endpoint and it's a failure, I do want to log it. So I do want to capture it. So I do stream it to a Lambda function. That Lambda function logs it. And at least if there's a failure, I could see in the log files there's a failure. And I could see the detail, a level of detail I want to see with the failure. So anyway, busy slide, but it's a very important aspect of writing mobile hub applications, to code this up right. And even though a lot of stuff is relatively simple in mobile hub, this is the part that comes right away. As soon as you build the mobile app, as soon as you generate the mobile app, you got to start implementing some of the stuff. You got to be configuring SNS. You got to configure this stuff, and it's got to work. So you'll be struggling with this right away as soon as you start building an application with the mobile hub. Okay, so now I'm looking at updating the endpoint, and I think we might have used a different strategy eventually, with or without an email ID. Okay, so when the user's authenticated, and they get the authentication token from Cognito identity, we can update the endpoint with the email ID associated with the authentication. Now remember, as an anonymous user, I didn't have the email yet. We were setting up to subscribe to topics within SNS, but as an authenticated user, you actually get a token from Cognito Identity. You're authenticated, so you can now update an endpoint with the email ID and store the endpoint locally. And so what happens is we have a situation where that event of updating the endpoint triggers an event in a topic which we created called Update Endpoint Topic. And when that occurs, we have a Lambda function which is registered with that topic, and the event gets triggered to that Update Endpoint Lambda function, and then we store the email ID and endpoint ARN into the DynamoDB database. Okay, so in order to make this happen, the administrator had to go in, create an update endpoint topic, and then they had to define an update endpoint app event, which will propagate the event to that topic. And then I had to take the Lambda function, register it with that topic, and in order to make all this happen. Very, very simple stuff. But trying to understand what you're trying to do with endpoints and user IDs and making a decision and moving forward is probably going to be your biggest challenge within the mobile hub initially. Okay, we're kind of talking about SNS now, when SNS, the mobile hub, gets the mobile hub application gets generated. What it does for you, it generates this all device topic, and it gives it certain permissions that that allow an administrator to push to the all device topic, and that all device topic is and SNS will then distribute that notification to all the mobile devices by communicating with Apple push notification services. So let's look at the steps involved, right? So the user they download the mobile application, they fire up the application, they get an unauthenticated token from Cognito Identity, and then they subscribe to this all device topic. Now, that what I just described comes out of the box. Mobile Hub is generating the application to do these things for you. So the first steps are done. As soon as you have the application and you fire it up, it goes and gets the token and it subscribes to that all device topic. The topic was created, the permissions were created, all the stuff was already created. But the groundwork of us being the administrator, pushing to the device topic, setting up SNS, the platform application, which is working in conjunction with Apple's notification service, and the preliminary steps that I discussed prior to this slide. There's some groundwork that has to be done. But the bottom line is, when the administrator pushes to the all device topic, SNS pushes to the devices through Apple's notification service. And I'm going to say this one more time. Anonymous users of a mobile hub generated application, as soon as users start using it, there's all the stuff that Mobile Hub already generated: the all device topic, the permissions. You already defined SNS and you configured it before you even generated the Mobile Hub application. So all this stuff is happening before the user even fires up the application. So out of the box, Mobile Hub has done a lot of work for you to give you what you need. As a matter of fact, a lot of the custom Node applications that I've discussed so far are for my own application functionality that I might need, which might be not as necessary as you might think. Okay, so once again, I have a push lambda here if I wanted it. When a notification gets pushed to the all device topic, I could have a lambda function listening and registered with that topic and store something in my database to keep track of what's going on, or log it in the console so CloudWatch could see it. Okay, so let's move on. This was the simple piece. Pushing notification to all devices, because Mobile Hub generated a lot of things for you, and anonymous users can get notifications, and pushing to all those mobile devices is relatively easy compared to the next scenario we'll discuss. Okay, so the next scenario we're going to discuss is a user A wants to send a notification to user B using their mobile devices. Okay, so first of all, I'm claiming that you have to be an anonymous user to do such a thing. Okay, so what I do is I use my access control policies to make sure that I have a Lambda function, invite friend Lambda. It's a Node.js application. The mobile application itself, when a user wants to invite someone, what I do behind the scenes, I use the Amazon SDK, which calls a Lambda function. It's behind the scenes a REST JSON-based web service call that goes to this Node.js application within Amazon realm, and the functionality is to invite a friend via notification service. Okay, so I claim that this Lambda function can only be invoked by an authenticated user. So one, Cognito identity has to recognize this user A as an authenticated user. 2, the Lambda function can only be invoked if Cognito identity claims that the request is from an authenticated user. So this user wants to invite a friend. So first of all, the user A says, well, I know John's email address, so I want to invite John. So we provided some functionality how the user can search the people that are associated with the mobile app. Okay, so 10,000 people downloaded this mobile app. User A says, hey, is user B around? And he searches, he knows this person, he searches for them and he sees their email address and he wants to invite them as a friend. So this user, okay, with this mobile device, which has an endpoint ARN in SNS as well as in my NoSQL database, wants to push an invitation. The only way user A can push to user B is if user B has an endpoint ARN. You have to send to endpoint ARNs and etc. So user B has to be a registered user, has to be authenticated, and also has to have an endpoint ARN, which means they're running the same application. There's a device token. There's an endpoint ARN on the mobile device, and it's also stored in a NoSQL database. This user wants to invite this email ID with this endpoint ARN. So this invite friend Lambda says, you want to invite that email address? Let me go get the endpoint ARN. It pushes the invite to SNS. Send a notification with this endpoint ARN. SNS says, let me push the invite to the Apple notification service. The Apple notification service understands how to translate the endpoint ARN to the device token. It understands the relationship. It's part of the application, the SNS communication. So it pushes the invite to the user B. If user B gets that notification, it can just view it. We implemented to retrieve the invitation from the invitation table. So sender sent to receiver an invited invitation on this date, and user B now has received that notification. Now, I can't stress this enough, is that there's different access control policies with different aspects of the system. The user had to get authenticated. The Cognito identity had to allow the user to authenticate, but Cognito identity used the Cognito user pool. Cognito user pool used the NoSQL. The Lambda is also reading from the NoSQL. The Lambda is also pushing to the SNS. Lambda has to have the right privileges to talk to SNS. Lambda has to have the right privileges to talk to NoSQL. So when you're in the Identity Access Management console, these roles have been created to do certain things within our system. And we could show you that in our next presentation, where I'll do an online demonstration of some of the aspects corresponding to this implementation. Okay, this looks a little bit confusing, but let's just take it from the top. Okay, user B now is going to accept the friend invitation. User B receives the invitation. Okay, now notice we have a table of endpoints. I use email IDs, endpoints. We have invitation table. Okay, so when the user B accepts the friend, the mobile app uses the SDK to invoke a Lambda function, which is a Node.js application. The Lambda function has to do a number of things. First of all, it updates the invitation as this user B has accepted it. It then wants to send a notification back to user A, so it has to go and get the endpoint associated with the sender. He received an invitation from a user A's email ID. Now he wants to send a notification. He has to go get the endpoint to go send a notification. So the accept Lambda says, I'm going to push a notification to SNS that we accept, but I need the endpoint of the sender. Also, I'm going to update the friends table because user B is accepted, so now A and B are now friends. So we updated a friend association table, and the Lambda sends a push notification. We accept push notification, and it uses the endpoint ARN of the previous sender. It pushes the notification, pushes the accept to the Apple push notifications, who pushes the accept friend notification to user A. User A receives that this user has accepted your friends, and then we invoke get friends on that mobile app to go get the list of friends. So there's another Lambda function called get friends, which I didn't list here, which will go and get the friends of this particular user, so the list gets updated. Because once the user has accepted and has another friend, user B, user A can now send to B a message. Okay, now this is simple enough. Both users are authenticated. Well, let's say user A is authenticated, and the user wants to send a message to user B, who might be logged in, might not be logged in. The application on the mobile device uses the SDK to invoke a sendMessage Lambda function. Of course, like I said, the user is already logged in, so there's a security token there that says Cognito identity identifies this user as an authenticated user. The user can now invoke a Lambda function because they're authenticated into Cognito. The sendMessage Lambda goes and looks at the email ID, gets the endpoint, logs the message, checks to see whether these two users are friends. Are they connected? They are. And then it pushes the message using the endpoint of the receiver. The message gets pushed. Apple Push Notifications pushes the message to the mobile app user. If the mobile app user is online, they see this notification. They touch the screen and the messages are retrieved, and they see the messages, including the one the user A just sent. Now, keep in mind, we are managing the endpoint ARNs. It's extremely important. You can implement a way to get them out of SNS, but it will be very inefficient, and you should not do it. Based on my implementation and the state which SNS was when we built this project, there was no querying capability in SNS, and there was too many endpoints in SNS to go and say, give me all the endpoints, let me check to find this one particular user. It's totally inefficient. You do have to manage your own endpoints. So you do need a custom Lambda functions to do what you need to do. Okay, so basically that's all we want to discuss. Next presentation will show you how to build a mobile hub, how to link to those web services, configure them, and how to generate the application. And then we'll show you how to configure a user pool with Cognito identity, and we'll show you some of the implementations that we have for our Lambda functions. And just remember, SOA Consulting Services, the AWS implementation experts.